All right, boys and girls, this is Math Message 5-7, the main math lesson of the day. And today we're going to work to identify patterns in numbers to help us learn our multiplication facts. Looking for patterns in numbers is really going to help you be able to memorize those facts, because when you understand how numbers work, the answers will just come easier. And I'll kind of show you what I mean as we move along in this lesson. Okay, I want you to get out your workbooks. Actually, before you get out your workbooks, let's look at this real quick here. I want us to look at the number grid, and I have some numbers covered. Which numbers are covered? So I want you to pause the video. I want you to write down what numbers you see that are covered, and I want you to think about how you figured that out. Go ahead and do that. Okay, so when I look at what numbers are covered, what do you notice is covered? First of all, 58 is covered up, right? How did you know that 58 was covered? And you might say, well, I know that 58 is between 57 and 59. I also know that as I'm going down the number grid, here's 48. And we know that when we're going down a number grid, we are counting by tens, right? So 58, and then if I go down again, 68, 78, and 88. So as we're counting down the number grids, and we looked at this a lot at the beginning of the year, understanding how the number grid is set up is going to help you with a lot of different things in math. Okay, so I can just, as I'm skip counting by tens, I can just kind of visualize this number grid. And I know that every number going down the column, in this column, is going to end with 8, right? So 48, 58, 68, 78, 88. And so as I come over here, the missing number would be 69. So coming down one would be 79. And over here, 70, going down one will be 80. Okay, so understanding that the number grid is set up so that as you move down the number grid, it is skip counting by 10. Okay, so now I want you to turn in your workbook to page 173, and it would be really helpful if you had a few different colored pencils or pens. So if you had like 3 different colors, that would be really helpful. And I'm going to use red and blue and green for mine. So if you have those colors, that would be great. Go ahead and pause the video, get your workbook to 173, and try to gather up some colors. All right, so the first thing that we're going to do, we're going to skip count by tens, and we're going to circle all of the multiples of 10 in red. Now, if you don't have red, that's okay. You can maybe just lightly shade them in. So skip counting by tens, we're going to start with 0. We've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So we've looked at this pattern already this year, and so we know that as we're skip counting by tens, all of the multiples of 10. Now when I say multiples, oh, I think I spelled that wrong. I put multiplies. Should be multiples. All of the multiples of 10. A multiple means that anytime I'm multiplying by 10, my answer or my product is a multiple of 10. So 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30. So 10, 20, 30, 40, those are all multiples of 10. And we know that when we have multiples of 10, they're all going to end in 0, and they're all going to make that straight line down our number grid. All right, so now go ahead and skip count by fives, and this time circle it in blue if you have it. If not, maybe just do it a little bit differently than you did the tens. All right, so we have 0, then we have 5, then we have 10. I'm going to underline it over here. Then we have 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, and 120. And then what do you notice about the patterns of the multiples of 5? So we were skip counting by 5s. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. So as we were doing our multiples of 5, what did you notice? Okay, so notice that everything ends in either 5. So everything was either down this column ending in 5, or everything was down this column ending in 0. And we looked at that already this year. We know that anytime we're multiplying by 5, the product is going to end in 5 or 0. We learned that one of our tricks for counting or for multiplying by 5s is to count by 5s, right? But we also learned earlier this year that when you're multiplying by 5, another trick is to pretend you're multiplying by 10, but then just cut that in half. So for example, if I have 5 times 6, I know that 10 times 6 is 60, right? And multiplying by 5 would just be half of that. So that would be 30. If I had 5 times 9, I'm sorry, I'm writing at my desk here, so it's a little bit jumpier. If I have 5 times 9, I know that 10 times 9 is 90. If I cut that in half, I have 45. So that was one of the strategies that we learned for multiplying by 5s earlier in the year. Another pattern I want you to notice. When I'm multiplying by 5, and it's an even number. So what I mean by that, let me see, I'm going to go to my smart board. All right, when I have 5 times 1, it equals 5, right? 5 times 2 equals 10. 5 times 3 equals 15. 5 times 4 equals 20. 5 times 5 equals 25. 5 times 6 equals 30. 5 times 7 equals 35. And 5 times 8 equals 40. 5 times 9 equals 45. 5 times 10 equals 50. Okay, I'm going to stop right there. What do you notice about the products compared to the factors that we are multiplying? Pause the video and take a look at that. And hopefully what you noticed is anytime I was multiplying by an odd factor, so 1, 3, 5, 7, 9, that's when my product ended in 5. Anytime I was multiplying by an even factor, 2, 4, 6, 8, 10, then my product ends in 0. So that's going to help me to know sometimes if I make a mistake. Like if I think that 5 times 8 equals 80, or equals 40, I know that, oh, I must have made a mistake because when I'm multiplying by an odd number, my product should be odd. So again, knowing these patterns is going to help you as you're multiplying numbers and help you realize, especially if you make a mistake. All right, so now the next pattern I want you to do is I want you to skip count by 9s and circle that, circle those multiples in green. If you don't have green, just kind of circle it or shade it in a different way that you did the other ones. So we've got 0, we have 9, 9 times 2 is 18, 9 times 3 is 27. If you don't know what it is, just skip count 9 more. So 27, add 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Go ahead and add 9 more. Where do you land? 45. Go ahead and skip count 9 more. 54. Skip count 9 more. 63. Skip count 9 more. 72. Skip count 9 more. 81. Skip count 9 more. Got 90. Skip count 9 more. 99. I'll bet you know where you're going to land next, right? And where do you think you'll land next? All right, so look at the patterns of the multiples of 9. And I want you to go ahead and go over to your workbook, and it's going to ask you some questions about the patterns of the multiples of 9. In number 1, you're going to describe the pattern you see. In number 2, you're going to tell me how is this pattern different from the 10s pattern. And in number 3, you're going to explain why the 9s pattern is a diagonal. Go ahead and pause the video and give yourself time to think and write on this page. Okay, I went ahead and put in some sample answers. So as we're thinking about this, so describe a pattern you see. One of the patterns that you should have noticed is that it made a diagonal pattern across the number grid, didn't it? So that's one of the things that you should have noticed. So I have here, oops, sorry, I didn't mean to go the wrong way. I see a diagonal pattern. I know that each number is down one row and one space to the left from the previous multiple of 9. And so what I mean by that is every time I went down one and back one, down one and back one, down one and back one, as I was skip counting by 9s. Okay? And then how is this pattern different from the 10s pattern? Well, with the 10s pattern, we went down a row each time we added another group of 10. So they made a straight column, didn't they? But with the 9s, we have to go down one row and then back one space because we're only adding 9. Instead of adding 10, we're adding 9. So, I mean, think about that. If we're adding 9, if we were adding 10, we would just jump straight down, but because we're adding 9, we also have to take one off. That's what creates that diagonal pattern, okay? With each number I add another 9, I can think of adding a row of 10, but then I've got to move back a space, okay? That's what's going to give me that diagonal pattern. All right, I want to look at, well, if we were in class together, I'd also teach you a cool finger trick for the 9s, but we'll save that until we are face-to-face. Now I want to show you some other patterns with 9s. 9 is one of my very favorite numbers to multiply by, and it's something that you'll get so good at it that, believe it or not, it'll be just as quick as multiplying by 10. You know, when I multiply by 10, put a 0 on the end, right? Well, you're going to find a really cool trick for multiplying by 9s that's going to be just as easy. All right, let's go ahead and set up 9 times 1. What is 9 times 1? 18, right? 9 times 2, oh, I'm sorry, skipping ahead. I'm thinking too far ahead. So 9 times 1 is 9. 9 times 2 is 18, and you can use your number grid to kind of help you. 9 times 3, what would that be? Go down and back, right? So 18, 28, take one off, it's 27. 9 times 4, think of my number grid. 27 plus 10 is 37. Go back 1, 36. 9 times 5, I'm going to, again, go down 1. So 36 plus 10 is 46. Go back 1. 9 times 6, I'm going to go down 10. So 55, go back 1, gives me 54. Now I'm going to go down 10 again. So 64, go back 1, gives me 63. 9 times 8, I'm going to go down 10. So 73, back 1 is 72. 9 times 9, go down 10. So 72 to 82, back 1 is 81. And 9 times 10, of course, I don't even have to think about that. When I multiply by 10, just put a 0 on the end. All right, now I want you to pause the video and look at the screen, and I want you to tell me some patterns that you notice. All right, one of the things I hope you noticed is when you're looking at the ones place, did you notice that it's going 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. When you're looking at the tens place, it goes, technically, you know, there would be a 0 there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's kind of a cool pattern, right? In the ones place, it's counting down 9, 8, 7, 6, 5, 4, 3, 2, 1. And in the tens place, it's counting up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a cool pattern. Now, that pattern's only going to help you if you really write out all of these nines multiplication facts, right? But you're not always going to have that all written out. You might just have 9 times 7, and you don't want to kind of start clear at the beginning and count all the way down through there. So this pattern only helps you when you have all of them written out like I do here. So let's look for some other things that you notice. Pause the video and see if there's anything else that you notice. All right, and this is so cool. I really hope that everybody noticed this. Did you notice when you multiplied by 1, the first number is, well, technically 0, right? When I multiply by 2, the first number of my product is 1. When I multiply by 3, the first number of my product is 2. When I multiply by 4, the first number in my product is 3. When I multiply by 5, the first product is 4. 6, 5, 7, 6, 8, 7, 9, 8, 10, 9. Isn't that cool? So whatever I'm multiplying by, the first number in my product is just 1 less. So I call that take 1 off. So I know if I have 9 times 7, let's say, I just know that my answer, I'm going to take 1 off, and my answer is going to start with a 6. But now I got to figure out what it's going to end with. So now I want you to look at the numbers together. What do you notice? 0, 9, 1, 8, 2, 7, 3, 6, 4, 5, 5, 4, 6, 3, 7, 2, 8, 1, 9, 0. What do you notice about the digits in the product? Did you notice that they equal 9? 0 and 9 is 9. 1 plus 8 is 8. 9. 0 plus 9 is 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. 5 plus 4 is 9. 6 plus 3 is 9. 7 plus 2 is 9. 8 plus 1 is 9. And 9 plus 0 is 9. So I call that make 9. So boys and girls, anytime you're multiplying by 9, here's my little trick up my sleeve. I'm going to take 1 off and make 9. So again, if I have 9 times 7, I know I'm going to take 1 off. So if my first number is 6, now I've got to make 9. 6 and 3 make 9. So let's practice some. What if I gave you 9 times 4? First thing you're going to do, take 1 off. My answer starts with 3, and now I have to make 9. 3 and 6 make 9. So 36 is my answer. What if I had 9 times 8? All right, let's look at this factor. Take 1 off. So my first digit is 7. Now I have to make my digits equal 9. 72. Okay, let's do 9 times 3. Take 1 off. So my first digit is 2. Make 9. 27. All right, so boys and girls, that is a cool trick for my 9s. I call it take 1 off, make 9. And you can do your 9s now super, super quick. Almost as quick as just adding a 0 to the end for your multiplying by 10, right? All right, the last thing that we're going to do, we are going to look for some more patterns in even and odd products. I need you to turn in your workbook to page 175. All right, now an even number of objects can be divided into 2 equal parts without any leftovers, right? We know that. When it's even, we can divide it into 2 groups with nothing left over. But an odd number of objects will have 1 left over if you try to divide it into 2 equal groups. And we know that. We've looked at evens and odds a lot. Now, I want you to use your multiplication division fact table and record some examples of multiplication facts with 2 even factors, record some examples with 2 odd factors, and then record some examples with 1 even and 1 odd. So here's what I mean. They gave me some examples. If I have 2 even factors, remember that word factor are the numbers in the multiplication problem. So if I have even factors, 2 and 8 are both even, right? So think of another set, maybe 4 times 6. All right, so go ahead and think of as many as you can that just has 2 even factors. Now in this column, 2 odd factors. So they gave you the example of 5 times 9. Maybe do 3 times 5. Okay, maybe do 7 times 7, right? So think of some multiplication facts with 2 odd factors. And then in this last column, you're going to do multiplication facts with 1 odd and 1 even. So they gave you 3 times 6 as an example. Maybe you could do 4 times 5. You know, as long as you have 1 even and 1 odd. All right, go ahead and pause the video, come up with as many as you can, but you're also going to need to answer them as well and make sure you have the correct answer. Okay, go ahead and do that. All right, so I went ahead and wrote down some examples as well. Now you may have chosen different examples, which I'm sure you probably did, but I want you to notice something. What do you notice about all of the answers, all of the products in this column here with 2 even factors? What do you notice about all of the products? Did you notice that the products are also even? Okay, now look at the column with 2 odd factors. So if both of your factors were odd, what do you notice about the product? Well, the products are going to be odd. And then what about the column where you had 1 odd factor and 1 even factor? What do you notice about all of your products? And even if you chose different answers, I'll bet you noticed the same thing. All of your products are even. This is another really important pattern for you to understand and to notice as you're memorizing your multiplication facts, because when both factors are even, guys, when both factors are even, the product is always going to be even. Okay? When both factors are odd, the product is always going to be odd. And if one factor is even and the other factor is odd, the product is always going to be even. So boys and girls, the only time when you're multiplying, the only time you're going to have an answer that is odd is if both factors are odd. Now that's going to help you because let's say that you're multiplying, let's see here, 7 times 8. And, you know, 7 times 8 is a tricky one. And maybe you get the answer 57. Well, you're going to have to realize that, ooh, this has to be wrong because the only time I can have an odd product is when both factors are odd. Okay, so that's another pattern that's going to help you as you're doing your multiplication facts. I need you to remember that the only time you will ever have an odd product is when both factors are odd. Okay, now that's also going to help you. Let's say that you're doing, 7 times 7, and let's say you think that it's 48. Well, both factors are odd. My answer must be wrong because my answer also has to be odd. All right, guys, that is it for lesson, I think we are on 5-9. Or no, we're not. I have no idea what we're on today, and I can't see the top of my screen. But this is 5-7, and that is it for that, looking for patterns in numbers.